Welcome to the Crazy Hat Chemist. So another video in bonding. Bam! So today we're talking about the unique properties of water due to hydrogen bonds. Okay, so one of them is that solid water, ice, is less dense than liquid water. And I want to show you another picture or another molecule here of water and another model. So here's a water molecule. The red is the oxygen, the white are the hydrogens. So this is a gaseous water molecule, and it's not hydrogen bonded. It does not have any intermolecular forces with any other molecules. Okay? And then here is ice. You should see that there's a crystalline hexagonal structure to this. Okay? And the hexagonal structure is that there's 1, 2, 3, 4, 5, 6. It's a 6-membered ring right there, as is a 6-membered ring right here. Okay? And all the purple things here are the hydrogen bonds between water molecules. So one water molecule, like right here, can maximally bind hydrogen bond 1, 2, 3, 4 other water molecules. And this expands the structure of water such that I have increased the volume and decreased the density, and that's why ice floats. Super cool. Okay, water is a liquid on our planet. Oh my gosh, that's super unusual too. Okay, that's because of its high boiling point. Okay, high boiling point means low vapor pressure and water boils. It has a very high specific heat. That means it takes a tremendous amount of energy to heat up water. Consequently, it takes cools down very slowly. That's why our temperature near the oceans, near large bodies of water, is relatively constant. Water has an extremely high boiling point compared to other molecules that have hydrogens in them, or other molecules that are similar in molar mass. And this is all due to the asymmetry of the water molecule and the fact that hydrogen bonds occur. And now hydrogen bonds are very weak forces, but if I have a cup of water, there's millions and millions and billions of hydrogen bonds in there. Okay? All right. So water molecules also have very high surface tension. That is, they like to form spherical droplets, and I'll show you a picture of that in just a little bit. So you can actually float a paperclip on water. This is a small paperclip. It's floating on the surface of water. It's actually below the surface of the water, but it's making an indentation in the water itself. That's because water likes itself so much and has these strong hydrogen bonds that are very difficult to break. Okay? Water has high surface tension. And I don't know if you've ever dove off of the high board of a diving board, and you realize that high divers, when they are really doing that dive, there's actually a stream of water that disrupts the hydrogen bonds. It disrupts the water surface. You don't want that nice crystal glassy stuff and to dive in there. It's like diving in like solid ice. It's not very fun at all. It hurts. Have you ever done a belly flop on water? That hurts. Strong surface tension. Okay, there's a high melting point for water, and it has a very unique crystalline pattern, and that's also due to the hydrogen bonds in water. Okay, water, as it freezes, it expands, and therefore lots of pipes rupture, and that's why you have to wrap your pipes that are exposed so that they're insulated, so that they won't freeze, the water won't freeze internally in them. Okay, water molecules form these circular drops. That means that they maximize the number of hydrogen bonds, and they form these circular type drops. It's really a beautiful thing. Okay, there's also a great deal of capillary action, and that's due to adhesion and cohesion forces. Okay, so some of these forces, so a capillary action is, as you see here in the tubes, these tubes decrease in diameter. So the smaller the diameter, the more the water molecules will travel up these tubes due to capillary action. And that is, water has a strong adhesion forces to the glass, and it will climb up it. Furthermore, cohesion forces, it will grab other water molecules with it. So it just kind of keeps on climbing up that very, very thin tube. The thinner the tube, the smaller the diameter of the tube, the higher those water molecules will travel. And this is the case inside trees. Those very small tubes in trees that bring water up to the leaves are like one water molecule thick. It's amazing. Okay, that's another Crazy Hat video from the Crazy Hat Chemist, and I'm going to give you all the luck in the world with my cool hat. Here, give me a thumbs up if you like that video. Subscribe to my YouTube channel. I would greatly appreciate that. Have a fantastic day, and I'll see you next time. Bye now.